that here. Now, two things are going to happen at the end. You get a PDF copy of the notes for the lesson for today. I still encourage you to take notes. I know you're doing homework, so obviously you've got to turn that in. And then secondly, we are recording. So if you miss anything during the lesson and you want to go back and review, it'll be available. I'll send you a link for that. It's actually on my YouTube channel. So unless you've got any questions for me, we probably ought to just jump right in it and see what we can accomplish. This is just a try it out lesson, just to see if you like the format. Have you ever done anything over Zoom before?
Yes, I have.
Awesome. So I know you're not quite ready to start. Do you need a few more minutes to get set up? Notebook, pencil?
Oh no, I'm ready.
You're already awesome. Okay. So at this point in the course, are you taking AB or BC calculus?
AB.
Okay, you guys are really far ahead of where most students are at this point in time, which is good. It could be a good thing. Usually students don't even see this until after the winter break. So all of these integrals you're solving using what are called u-substitutions. Did you see that in class today or in the last few days?
Yes.
Okay, you've seen these before in other classes. Now, we're going to go through some guidelines about what to choose for u-substitutions. But for the first one, I'm just going to tell you what it is. Your u is x squared, and then you have to do a couple of things. You have to take a derivative, du, of both sides. Derivative of x squared is 2x dx. So you have to put that du and dx here, and then you have to solve for dx. This may be slightly different than what you've seen in class, but I think you'll like this approach as well. So dx is du over 2x. And then you're going to go back into your integral. And this is perhaps the hardest part, is you're always going to replace your whatever your u is and for dx. And we'll see what happens. So the x you don't have a substitution for. Cosine, instead of x squared, it's now of u, because u is x squared. And then dx is du over 2x. Now, do you notice that the x's now cancel? Do you see that?
Yes.
Okay, and that's important. So whenever you're making this u substitution, you're effectively eliminating x, or whatever variable of integration you're using in this problem. It's good to be a little bit more, what's the right word here? We want to write everything out. So do you like to bring the constants outside of the integral or leave them inside the integral?
I think our teacher said bring them out, but
it doesn't matter. It's actually, you get a choice here. It's just some students have a preference. I'll bring it out here. So you're supposed to, at this point in the course, know what the antiderivative is of cosine. Can you tell me that?
Is it positive sign?
It is. It's sine u. You bring that 1/2 down, and then plus c, that constant of integration. Now you might think you're done, but you always have to back substitute. And you saw this in previous courses. So you take that u value and you put it back in here. So it's 1/2 sine x squared plus c, and that is your final answer for this one.
Okay, yeah, I get that.
Any questions on that?
No, I think I get that.
Okay, let's do another problem here. They're all the same type, meaning they're all u-substitutions. And again, we'll get to a list of like what to make this, how to decide what to make the substitution. That's really the hardest part here, is you as a student saying, well, what is my substitution? So I'm going to be kind. I'm going to just give you the substitutions for now, but eventually I'll ask you to sort of see if you've got any ideas of what it may be.
Okay.
So your u in this problem is 3 sine x plus 4.
Yes.
Right? And can you tell me what the derivative is of 3 sine x plus 4?
Would it just be -3 cosine x?
Derivative of sine is cosine. So you want to get really good at this sort of mapping where derivative of sine is cosine, derivative of cosine is minus sine x, derivative minus sine x is minus cosine x, and then it repeats back. Have you seen that before?
No, I have not.
Okay. It's kind of like, did you ever remember where there was like I is squared root of -1, I squared is 1?
Yeah.
It's kind of like that. And you want to get really good at remembering this. So what I like to do is create a list, because you're at this point in the course where you're either going down with derivatives or backwards with integrals, and you have to be comfortable going both directions. Okay, so lot of words there to say that the derivative is 3 cosine x. What about this 4 on the right? What is its derivative?
Just 0, right?
0. Yep. Now you need a dx. That's something maybe new here. And then I like to always solve for dx. Some teachers don't emphasize that, but I think it's really important to solve for dx. Dx is du over 3 cosine x. And this is kind of all off to the side. Like if you remembered the first time you learned product rule or quotient rule, you might have went off to the side with u and v or f and g. It's part of the problem, but it's kind of your side work, if you will. Okay, so we go back to our integral, and 3 sine x plus 4, well, that's u. So we have u to the 5th, cosine x, and then we replace dx, du. Dx is du over 3 cosine x. And wouldn't you know it, the cosine x's cancel. All right, so now the integral is 1/3 integral u to the 5th du. Do you remember the integral of u to the 5th? Can you tell me that?
Like 1/6 u to the 6th.
That's correct. It's the power rule. You've got this 1/3 plus c. Can't forget that. You get dinged for points there. And then you do have to back substitute your u. So your u in this problem is 3 sine x plus 4. And so it's 1 over 18 parentheses 3 sine x plus 4 to the power of 6 plus c. And that is your final answer on that.
Mhm.
All right. Do you have these notes down?
Yes.
Great. Okay, now just to kind of summarize what we've done for 2 problems here, our u in both problems was in parentheses.
Yeah.
Okay? And that is something to be on the lookout for. Now, it's not always the case, as you'll see here, but that is really the emphasis of this part of the course, or this section, is not just doing the u substitution, but like, what is the u substitution? So if you had to make a guess here, what do you think your u might be in this problem?
Square root x.
Square root x, yes. Okay. Now at this point in the course, I would absolutely love it if you could just tell me that this was the derivative. But if you need to go back and say, okay, it's u to the 1/2, and then I'm using power rule, so it's 1/2 u to the minus 1/2, and then that's 1 over 2u to the 1/2, and then you eventually get to this, that's okay. But you want to be able to do it the way I just showed you, because you're going to do square root of x a lot in this course. And you want to get really fast at just being like, yeah, it's 1 over 2 square root of x.
Okay.
All right, so when you solve for dx, this time it's 2 square root x du.
Yeah.
Okay, and it's really important that you do that, because you're going to substitute this back in, and you're going to substitute the u, and you're going to see some hopefully a cancellation. So it's sine u over square root x, and then your dx is 2 square root x du. And again, you get a cancellation. Now, there are problems where it doesn't cancel, and there's a couple of possibilities. I don't know if we'll see one in this lesson today, but in general, you should be just down to your single letter. And oops, let me get that back. You oftentimes get a constant. So this is 2 integral sine u du. And again, I made that list earlier, sine x, cosine x. This is going down derivatives, minus sine x minus cosine x. So when you're going down, that's derivatives. But when you're going backwards, it's integrals. So the antiderivative sine x is minus cosine x, or minus cosine u, with that 2 out in front, plus c. So this is derivative, this is integral, direction. And then you got to put that u back in. minus 2 cosine square root x plus c. Sorry, I pointed at the wrong thing. It's your u is the square root of x. How did you do on your last exam?
Well, that was just like our derivative exam. That wasn't like we haven't had an integration exam yet.
Right. I was just asking how your mom mentioned you had one on like
Um,
Tuesday. So just
I
curious how you
got
did on that.
I got like a B.
Okay.
Yeah,
Excellent.
I got an
Excellent.
84.
Great. So we'll talk more about testing stuff as we continue to work together. So far, in terms of your u substitutions, here are some guidelines. I'll give you some guidelines now. So it's in parentheses. Okay, it's under roots. We'll get to that at some point. It's denominators and its exponents. There could be a few other things, but this is kind of your list. This is what you're looking for. Okay. But most importantly, and I'll start emphasizing this now, the most important thing is that whatever it is, the derivative of u should be in the integral. And that's more of like an overarching thing that you're looking for. So for example, here, I'm going to help out here. Let me actually frame this differently. Let me put this down below. So let's just say you thought u was x squared. What is the derivative of du in this case?
It would be 2x dx.
Perfect. Now my question to you is 2x in the problem?
No.
No. So this is the wrong u. And that's where the students struggle here. That's where this assignment could take like 3 hours. Because if it's like, you ever gone like hiking and went down the wrong path and you get, you're like, oh, I have to go back, start again. That's what's going on here. Like you have to choose the right u. Okay, and that's where this is so challenging. So the correct u in this case is the denominator. It's x cubed plus 5. Can you tell me its derivative?
3x squared.
Anything else?
No.
How about the dx?
Oh yeah, dx.
Yeah, plus 5. There's obviously nothing there. Now, this is a you may not answer this correctly. I'd like you to at least think about it. Is 3x squared? Is 3x squared in the problem?
Yes.
Kind of is. Like it is, but it isn't. It's x squared. But that gives you some like positive, like, okay, I think it's probably there. I feel like I'm on the right track. Okay, so your dx is du over 3x squared. So now you go back to your original problem. Okay, and you substitute in, if it's unclear, you always put your u in wherever that goes. The x squared I like to keep. Some people try to cancel it out. I like to leave it in and see that it cancels out here as part of this. Okay, so now the x squareds cancel. And you're left with 1/3 and then 1 over u du. Do you remember the antiderivative of 1 over x?
ln x.
Yes, good. Good. So it's actually the natural log of the absolute value of u in this case. And that absolute value is super important in this course. Definitely would get dinged for points on the AP if you didn't show that. But that is it. Now, we're not done because you have to back substitute your u. Your u is x cubed plus 5. So that's what goes inside the natural logarithm. Something like that. Any questions on that?
Yeah, I get that.
Get that? Okay. So of course, now that you get it, we move to problems that are actually very different. So before we move to those, let me go down to example 2, because this is a better continuation of the work we've been doing, and just talk about what you're going to see here. We'll, if we've got some time, we can go back, of course. Okay, so in this problem here, do you remember the difference between this symbol here with the numbers and then the previous problem where it's just the symbol? Do you remember that from notes or class or anything like that?
Yes, but not like entirely. Like it recognized it, but like it's still like
So when you
fuzzy.
so when you have two numbers, it's what's called a definite integral. Okay, and I'm not big on like names and stuff like that, but what you need to know is you're going to get a number. Your output is a number. And if you look at the previous problem, did we get a number?
No.
No, we got a function. But here you're going to get a number. And so sometimes they're better. In truth, you can do this in your calculator, like the TI 8384. Yeah, you do have to do it by hand as well. But when you get closer to the AP, there'll be more complicated problems where you will use your calculator, but you have to know that I'm getting a number, getting a number, getting a number. But you first treat it as if like you don't care that there are bounds on your integral. Just like, whatever, I need to integrate this thing. So you have to figure out your u substitution. So I mentioned that u is sometimes what is under the square root, or the root in this case, x to the fourth plus 5. Can you tell me the value of du?
4x cubed dx.
Perfect. Now you want to visually inspect and say, okay, is x cubed in the problem? Not part of the u, but the rest of it. And you're like, yeah, it's right there. So that gives you some confidence, like, I think I'm on the right track. Okay, now until you've done, I don't know, we'll say 100 of these, you probably will never fully know that you were on the right track. But this helps. Okay, so this becomes the integral. And I'm not going to write the bounds, and that's intentional here. We're going to talk about that for in a moment, but let me just write it without the bounds. Square root u dx, well, that's really bad. Let me not do that. Square root of u, and then du over 4x cubed, like that. So notice the x cubes cancel. And this becomes the integral square root of u. Now I like to change that right away to a u to the 1/2, because I'm going to use the power rule. I get that. Now, did you do any of these definite integrals in class?
Yes.
Okay, so there's a choice right here. There's two paths you can take. The first path is you can integrate as is, okay, meaning like with respect to u, and then you back sub x, the x in, okay, and that's one path. All right. The second path is you can change the bounds. Okay, the limits of the integration. Maybe I should say it that way. They're not the bounds. I guess they are the bounds of the integral. You can change the limits of integration. Do you remember what you did in class? It's okay if you don't. I'm just asking.
Can you repeat what you just said?
Yeah, I'm asking you, do you remember what you did in class? Do you remember if you just integrated it like this and then back substituted in for x, or did you change the limits of integration?
I think we chose the limit of integration.
This, yes, you can actually do either, and it kind of depends on the problem. So there's a lot here, like we're doing a lot, but to do that, you go back to your u substitution right here, okay? And you basically evaluate your u at each of the bounds. So you treat your u like it's a function, because it truly is a function of x, and you put that 1 into the function. So it's 1 to the 4th plus 5, which is 6, and then u of 2 is 2 to the 4th plus 5, which is 31. Sorry, 21. Like that. Are you able to hear me okay? Just
Yes.
curious. I'm not having any issues with my,
Yes.
sometimes there's issues, but 6 to 21 are our new limits of integration. And this is the better choice here because it makes things a lot cleaner once you integrate. So your antiderivative, what's your antiderivative of u to the 1/2? Can you tell me that?
Wait, I have to think.
So you're always adding 1 to the exponent,
So 3
3/2,
Three
Yep.
halves u to the 3/2.
and then you divide by the new exponent.
Yeah.
Okay, now there's a bit more to be done to simplify this, but that's in principle what you're doing. Now, what a lot of students do is they know to flip the fraction. So they say, oh, I've got to take the reciprocal of that. And then like you did, they've got to be able to add it. And then you need your limits of integration here.
Oh, okay.
Is there anything I've done here that is unclear?
No, yeah, I get it.
Get it. Okay. You simplify the stuff in front. That's what do we got here? 1/6 u to the 3/2, evaluated from 6 to 21. And you probably have seen this here. It's top minus bottom. Okay, so it's okay to just say 21 to the 3/2 power minus 6 to the 3/2 power. That's okay. And I mentioned you get a number. Well, this is a number. It's just not a very aesthetically pleasing one. It's a bunch of things. But this is correct. Any questions on that?
Yeah. So would you have to simplify that or?
The answer is yes, but this one cannot be simplified. So like, let's say it was like 2 to, I'm sorry, let's say it was like 4 to the 3/2 power. This one we could simplify, but 21 doesn't simplify in this case. And the reason is because 4 can be written as 2 squared, an exponent to an exponent, you multiply, so this becomes 2 to the 8th, or sorry, 2 to the cubed, which is 8, and it does not work out. So this is sufficient
Okay.
for most. All right, so let's do one more problem here, and then I'll ask you to get your mom in here. We'll get some feedback or talk to her as well. But let's look at this one. It's kind of the same type of problem in the sense that it's a definite integral. You're going to get a number out at the end, but you don't know how to integrate this. That's the whole point of this u-substitution today, is you don't know how to integrate it. You don't know what you're doing. It's not a known one. So you have to do something else to transform it into something you do know. And your u in this case, any idea what it might be? Do you want to take a guess at that?
Would it be the negative t squared over 2?
Yes, and it's the whole exponent, okay? Like it's never part of the exponent, it's never part of what's under the root, it's everything. It's everything under the root, everything in the exponent, everything in the denominator. It is extremely rare for it not to be everything. Can you tell me what du is in this problem?
Wait, I have to write it down.
Sure.
Would it be negative t?
Yes. Anything else?
Dx.
dt in this case, because it's and it's okay if you switch those, but just keep in mind that's important. So your dt is du over minus t. Okay, I know it's odd to put a negative thing in the bottom, but it's just, I like to keep the du separate. That's my little preference. Now we should evaluate the limits of integration. We should put 0 into your u to get out the new bounds. So that's 0. Then you have 15. So this one, notice it's not great. Like it's gonna be minus 15 squared over 2. So it ends up being minus 225 over 2. We may find that it was not the best to do this. I don't know. Sometimes you can't tell. You don't know until you've done a few of these. But here it's minus 225 over 2 t e to the u, because u takes the place of all this. And then dt is du over minus t. And what we're hoping for in this problem is that the t's cancel, because we don't want to have any t's in there. You don't know how to integrate when there's more than one variable, and that's a different course altogether. So you don't have to deal with that in this one. So it's just negative e to the u du. E to the u is the best one, right? It's like, yeah, give me e to the u integrals all day long, because it's e to the u evaluated from 0 to minus 225 over 2. It's just itself. Hopefully that's clear. Okay, and then you got to put these values in. So it's minus e to the minus 225 over 2 minus the bottom, so it becomes plus e to the 0. E to the 0 equals 1. So in terms of presenting your answer, you switch. You put this first 1 minus e to the minus 225 over 2. It is a number, but doesn't mean much. It's not like it's a quantity that we use on a day-to-day basis.
Mm-hmm. Yeah, that makes sense.
Okay, so we obviously didn't get through everything. So my lessons are normally about 50 minutes. Let me do something real quick before you grab your mom, just so you see this. You may be the more of the technology person in your household. So all of my booking is done through my website, tutoringbymatthew.com. And you just go to schedule a meet with Matthew, and that's me, obviously. And then you just choose the date and time of the lesson that you want for the virtual lesson. So it gives you over a week out. So you could schedule here into November if you wanted, but you choose the time and takes you through the booking process. So if your mom's around or dad's around, they want some feedback, I'd love to talk to them.
Yeah, I'll be right back.
Sure, sounds good.